Not many other technologies have kind of these tools, or many wireless technologies have these tools in their toolbox. So I think that makes Bluetooth quite unique for applications like this.
In this episode of Embedded Insiders, Miko, Silicon Labs Senior Product Line Director of Commercial, joins the podcast to discuss the partnership between Silicon Labs and Emanate Wireless on the Radio Vision solution. The battery-powered, AI-enabled Bluetooth doorway choke point system is a real-time location system designed to help hospitals accurately track staff, patients, and equipment. Next, Rich and Simon Ford, the founder of Bleacon, discuss the joining forces of Bluetooth and industrial and how Bluetooth is enmeshed in the industrial sector. But first, we're highlighting some recent research from Penn State on DNA-based data storage. Researchers have combined synthetic DNA with electronic materials to create a brand new kind of computer memory. Hello, everyone, and welcome back to the Embedded Insiders podcast. I'm Assistant Managing Editor Tiara Oliver, joined with our Editor-in-Chief, Ken Briota.
Hello, Tiara, and how are you on this fine day?
I'm good. How are you?
Healthy at the moment. We are having ourselves a winter here in New England, which is where I live, to you folks out there listening. And hopefully we're going to be pretty much done with it now. I like the winter, but this is a lot for 3 days worth.
I know. It's crazy how we're on such contrast of weather, you on the East Coast and me on the West Coast. And I'm getting like back to high 80s this week.
Oh, sure. Brag about it. Why not?
I'm going to miss it.
I'm excited for 40 tomorrow, perhaps,
Yeah.
So you sent me a super interesting article that I would love for us to talk about for a minute. I think all the listeners would be super interesting to hear about this. Why don't you give us the brief on this Penn State research article?
Yeah, so I was looking for a topic to discuss for the intro of this podcast and just doing some Googling and came across posted yesterday, February 24th, and it's basically DNA-based data storage. Scientists outside of or at Penn State figured out how to combine synthetic DNA with electronic materials, which kind of is designed to support a new kind of computer memory that's just less power, can store more data, and is more brain-like, basically.
That's first of all, that has been like a storage and memory goal forever, because and it says it right in the opening graph of the article, which we'll put into the show notes, so you can check this out, folks out there. But DNA can store somewhere around 215 million gigs of data per gram. So, like, obviously, trying to figure that out with by creating a synthetic DNA has been a big deal. They've already applied for a patent. That means that they've got it working. Ideally, it's not necessarily you can patent the idea and prototype, but it looks like they've got a pretty solid lead here. They created what they're calling a memristor.
Yes.
Which is crazy. It seems to be super low power. What a cool thing. I mean, storage and memory is becoming more and more important. I mean, this is tiny memory. It'll be interesting to see what because the storage is one thing, the retrieval is another. It'll be interesting to see how fast retrieval is, what kind of fidelity of data you get back. Like, is there degradation or anything like that? Obviously, tons of testing to go, but like, this is such a cool piece of tech.
Yeah, it's like this really interesting way to view our technology and our industry, but we're coming from, or as the article says, borrowing from biology, which is I don't even know what to think about it, honestly, but I think it is hopefully something that can stay in the realm of positivity. We don't go too crazy with it or anything, but
Yeah.
um,
I mean, yeah, you can think all the way out to like sci-fi concepts, like
yes.
importing this synthetic DNA into biological organisms so that we have infinite memory and like the old Matrix thing, I know kung fu, that kind of that kind of thing, which would be very cool. I would happily learn a variety of things that way. But as we're learning with generative AI, that's not really learning. And so I'm not
Yeah.
super a big fan of it in the real world. It's awesome in a movie. Um, but this seems awesome. I'm so excited to see what the testing is going to be like. Um, it's nanoscale. They're saying that it's going to be really low power, so obviously I immediately think of the edge, but I bet if they figure out how to scale it, we're going to hear about data centers exploring this. It should be really really interesting.
Yeah.
So yeah, I'm really excited. I'm going to be keeping an eye on this, and I think you folks out there listening should as well, because this is really really cool.
Yeah. And for those of you who can't get to the article right now, basically we're combining synthetic DNA with a semiconductor material called perovskite, and then adding also silver nanoparticles. And that's what's combining this whole biohybrid electronic memory solution. So,
Werewolves
um,
beware. Um,
yeah.
Um, but this is exactly the kind of thing that I'm hoping to see in a couple of weeks at Embedded World. We're going to be there checking out a lot of new tech. You and I are deep in up to our elbows in the judging process for the Best in Show Awards.
Yes.
There's some really interesting technologies there for sure. Keep an eye out for that winner announcement. It'll come out the Tuesday of the first day of Embedded World was out. Um, but yeah, there's going to be lots going on. We're going to be recording podcasts and posting tons of video. It's Sarah's first time at Embedded will be super exciting, I think.
Yes.
Um, yeah, I'm really excited for it this year. I think it's going to be really really good. I mean, what about you? What are you looking forward to?
Honestly, I've just been going to smaller events in this industry and always hearing about how big and cool Embedded World is. So I'm honestly just excited to step out on the show floor and see everything and hold some meetings and shoot some content. Never really shooting content. So I'm excited for all of it. Nervous, of course, but I know it'll be a good time overall. So
No need to be nervous. You're going to do great. We'll just have to, keep the thronging masses of your fans at bay. Um,
exactly.
so you hear that, folks out there listening? I know you're all big Tierra Oliver fans. You can try, but we got tight security. So don't think you're going to get through our
Exactly.
cordon.
Exactly. Yes, everyone stay tuned. Keep an eye on our site, keep an eye on our YouTube for sure, and just keep an eye out on what we've got going on. It'll be a lot, so stay tuned.
Absolutely. Don't forget to subscribe if you haven't already. I know like 90% of you that are listening to these are not yet subscribed. You could miss out.
Now, here's Miko, Silicon Labs Senior Product Line Director of Commercial. So, Miko, can you tell me about yourself and your role at Silicon Labs for those who don't know?
Hi, my name is Miko. I'm a senior product line director at Silicon Labs. I'm responsible for commercial business at Silicon Labs, and what commercial covers is various applications from automotive applications to anything we do in commercial smart buildings, enterprise IoT, and also asset tracking, which kind of fits our topic today.
Sounds good. Speaking of our topic today, I kind of want to get just a basic landscape of the overall, challenges or needs that you believe are surrounding connected healthcare today. What's it looking like?
So if we kind of specifically talk about the asset tracking piece, as connected healthcare can things from medical devices worn by consumers for glucose monitoring or insulin delivered to heart rate monitoring. That's kind of very different application versus what we see in the kind of clinical asset tracking space. Asset tracking, it's essentially about becoming more efficient, either knowing, where your people are, where they're spending their time. In the commercial healthcare space, it might be tracking patients, making somebody falls over, knowing where they are so you can send help. But it's also about tracking expensive equipment. As I'm sure we can all imagine, hospitals are full of expensive equipment, and they get lost in hospitals, and that has led to a situation where people do spend extra investment in having more equipment than they basically need, so they spend less time finding them. So when you talk about real-time asset tracking solutions in these spaces, it's essentially becoming more efficient by having less expensive equipment and spending less doctors and nurses' time on finding where people or that equipment are.
Sounds good. You kind of touched on my next question a little bit, but can you walk me through the radio vision solution? How does this battery-powered AI-enabled Bluetooth doorway choke point system and the real-time location system, how does it look and operate for the medical professionals that are using it?
So, because Animate is probably the more expert in explaining what their product is.
Okay.
Usually how these solutions work is, you tag the assets that you want to track. So you either attach a small asset tag if it's an equipment. If it's a person you're tracking, it might be something you wear, like a badge or a wristband. And as those things move around, they need to be battery powered. They need to be able to transmit their location or some RF signals that the infrastructure can then use to determine their location. And they need to have years of lifetime, as we don't want changing batteries frequently. Consumes people time, and we want to reduce the amount of environmental waste we produce. So the basic concept is whatever you want to track, you need to tag it somehow with almost in every case a wireless device transmitting RF signals being battery powered. Now, to be able to locate your assets where they are, you're going to need some infrastructure in place. Typically, this infrastructure, it can be portable devices, handset scanners that are used by people. But in case of Animate Wireless, they're actually what we call locators or access points. So, piece of hardware that typically gets installed into a room in a hospital. In hospitals, of course, multiple rooms, and they're responsible of, listening where these tags are and determining their location. And then typically that information gets transported to, cloud infrastructure. And then users will have some sort of dashboards, mobile applications, and so on to, see where those assets are and go and, find them as efficiently as possible. One unique thing about this solution is the infrastructure is battery powered. Some of that infrastructure is mains powered, Ethernet connected, which makes installation a lot more costly. Because in many cases, when this infrastructure gets deployed, the largest cost is essentially pulling wires. So making sure there's electricity available, making sure there's Ethernet available. And with wireless infrastructure and our battery-powered wireless infrastructure, you can reduce the installation cost significantly and remove that cabling aspect out of it. And that reduces the investment cost to deploy these solutions, which then translates to far faster return of investment for the hospitals. So they're more, let's say, they can more easily deploy these solutions because the installation cost is reduced.
So let's talk a little bit more about the Silicon Labs SoCs, I think the BG22 and the MG26. You know, how do SoCs like that support medical IoT compared to maybe earlier wireless platforms?
So there's kind of this solution, as I explained it, typically consists of two solutions. There's the asset and the tag you want to track, and then there's some infrastructure responsible for tracking. So BT22 is used on the tech side of things. BT22 is our lowest power, let's say most affordable, most optimized device for these asset tags, which really enable affordable asset tags to be built, which can run years on coin cell batteries. The MT26, it's a higher end device that's used on the infrastructure side. It's essentially responsible for discovering the tags. And then there are the algorithms that compute the location of those tags. And, you need more processing. That's why, for example, they use our AI accelerator, because these positioning algorithms are mathematically complex. And require more resources. So that's where the MT26 excels. It has the right resources, the memory footprint, the AI accelerator to run the computational algorithms needed to discover the asset tags. So that's kind of the high-level overview how the Silicon Lab solutions play into this.
Mhm. And what made Bluetooth, I guess, the right foundation for this solution versus, other wireless technologies, in your opinion?
So Bluetooth is in a great position for this application. There's multiple reasons for it. Bluetooth is such a widespread technology. It's easily accessible by people. People do understand very well how Bluetooth works. It's extremely low power, supporting the battery asset tags that need to run for years. And Bluetooth has some unique capabilities when it comes to these real-time location solutions. What we kind of tend to call the locationing toolbox for Bluetooth, and it probably has three major things you can do. For the simplest location solutions, the Bluetooth devices just broadcast their presence. So it's basically like shouting out, "Hey, I'm over here." And you can detect the signal strength from that broadcast. Based on that, you can do rough estimations where the devices are. You can't get to accurate position, but not every application needs accurate position. Now, if you go to these hospital applications, one key performance indicator over there is you need to at least to get to a reliable room level accuracy. So when you send a nurse out to find a patient or find a piece of equipment, you want them to get to the correct room, not the room next to you. So you need something which is more accurate than the pure signal strength based solution. And the second thing in the Bluetooth toolbox is something called angle of arrival and angle of departure technology, which is utilized in this solution. And with this technology, you can get the direction of the signal. So, from which direction the signal comes from. And with that information, you can get to a more accurate position than just, something 10 meters away or 5 meters away. In the very recent developments of Bluetooth, and these solutions are only being deployed or let's say developed as we speak. The third tool in the Bluetooth toolbox is something called channel sounding. What channel sounding gives on top of the previous solutions is accurate distance measurement.
Mhm.
So then you can measure distance between two Bluetooth devices, something which has not been possible with Bluetooth before the introduction of channel sounding. And that can furthermore enhance these positioning solutions, because now you can get three things. You can get rough presence based on signal strength. You can get the direction of the signal, where it comes from. And then channel sounding can add distance measurement on top of that. So Not many other technologies have kind of these tools, or many wireless technologies have these tools in their toolbox. So I think that makes Bluetooth quite unique for applications like this.
Sounds great. I kind of want to talk about the collaboration between Labs and Emanate. So, and kind of how it began. How did the hardware software co-design process between the two companies, shape the final system architecture?
So I wasn't personally involved in the let's say the technical details of the
Mhm.
cooperation. Usually how this works with our customers, they see us as the wireless experts.
Yeah.
Of course, many of our customers are wireless experts themselves, but usually cooperations like it, start with technical consultation. We explain, to our partners and customers, what are the possibilities with the technologies we do. What are the limitations. What we think is possible. What may not be possible, and then we try and figure out, does that fit to the use case. Our customers and partners are trying to accomplish. So it starts as this typical consultation process where we both try to find what works, what doesn't. In the when the development starts, we do help customers with various aspects of their design. We can review their hardware designs. Some cases we do performance testing for them, measure RF performance. In the case of these location technologies, we can help them, measuring, how accurate position they're getting, or how accurate the distance measurement is they're trying to accomplish, and give them some guidance, how to improve things if needed for their application. And the same happens also on the software side. Many times we enhance our software solutions, or work together with our customers to add features and functionality needed by their application. As we tend to be experts on implementing protocols like Bluetooth, or even higher level applications like positioning algorithms on top of the Bluetooth communication. So it's a multi-stage collaborative process, starting from how to realize the use case, and then moving on, how do we get through the development phase, and start helping our customers having ready products on the market.
Right. So, I guess in your opinion, how do you foresee this innovation of real-time location and automation in healthcare maybe evolving over the next few years, just in your opinion?
But real-time location, it's a hot topic these days. Everybody wants to improve operations, become more efficient, reduce expenses in capex, and not investing into more equipment than they need. However, especially when it comes to indoor location, I don't think that there's not necessarily a holy grail solution yet. There's multiple solutions, from Bluetooth to ultra wideband to millimeter wave radars, and each of them have pros and cons. One thing which is for sure, all these technologies keep improving as we move forward. Like I explained previously, we're just adding this channel sounding technology in the Bluetooth, which gives another capability, and with distance measurement to bring more accuracy, or new types of use cases for locationing. So that's that development I see continuing, and improving as we go forward. Also in the wireless space, we do see gradual improvements with all these technologies. It's either our performance becoming better, power consumption going down, or the technology becoming more and more affordable, for these types of applications. So multiple developments on multiple fronts, I would say.
I think that's all the questions I have for you, Miko. But as always, I'd like to know if there's Anything I might have missed or anything else you'd like to add about this collaboration between Silicon Labs and Emanate, about the radio vision solution or about the SOCs that you guys are using?
Well, I think we covered the most important topics I wanted to discuss.
Mhm.
As we, as like I said, with many of our customers and partners, it's a collaborative way of working. We as time moves forward, we probably see an evolution in these systems. Improved accuracy, increased battery life. Or other advancements as our customers learn what the market needs, and as we educate them, what's possible with technology and the developments and evolvements we see over there. So I'm sure there's going to be more we hear from this or similar applications in similar spaces.
Sounds great. Thank you, Miko.
All right, thank you.
Now, here's Simon Ford, founder of Blecon.
Good afternoon. My name is Rich Nass. I am with Embedded Computing Design. My guest this week is actually a repeat guest. He did so good, we asked him to come back. Simon Ford with Blecon. How you doing, Simon?
Very good. And yes, it's great to be back talking to you, Rich.
You know more about Bluetooth than almost anybody that I know. However, this discussion that we're going to have, in my opinion, is a little bit challenging because we're mixing industrial applications, Industry 4.0, with Bluetooth, and you generally don't hear those two terms mentioned together. So why are we talking about Bluetooth and industrial?
Yeah. Bluetooth, as you say, it's a very well-known technology, and very robust in even in noisy environments. So from a technical point of view, it's a great technology. But the real cheat that it has is it's embedded in loads of mobile devices. And what's been happening over the last, I guess, 5-10 years is mobile computers are becoming essential to how businesses run their frontline workers. The reason Bluetooth is suddenly
Let me
coming up
interrupt
on
you
the
there
radar.
for 1 second, because I like to interrupt. When you say frontline workers, who are you referring to? You're not talking about the people who are on the factory floor, right?
No, absolutely. Yeah. People on the factory floor, people in warehousing, people in logistics. I mean, maybe it's outside the topic of this conversation, but even into, the environments like shops and things like that where work gets done. So, yeah, by frontline workers, I really mean people on the front line doing things, moving things, making all these companies operate. Yeah.
Okay, I'm preempting your discussion, but I'm going to do it anyway. Don't these people already have Wi-Fi embedded in all their devices anyway?
They do, yeah, and that's how they're on the networks. That's how they're on the internet. So all of these devices they're carrying around, they're already connected. To do their job, to be told what task needs to be done next, to interact with objects around them, scanning barcodes, whatever it might be. These devices are already purchased. They're already on the IT systems. They're already blessed by security, et cetera, et cetera. They're already getting charged up every night. These devices that companies have made a huge investment over the years in this type of technology, and it really is how companies now operate. The fact that these connected devices are already out there is the reason why Bluetooth suddenly becomes interesting, because they can take on another life of actually not just interacting with the person that's holding them, but interacting with objects nearby. And that's where it's getting really interesting for us.
Okay, I'm confused though. Why would you use Bluetooth and not the Wi-Fi?
Well, I mean, for the applications people are looking to do, it's things like identifying objects, tracking objects, getting sensor data out of things around the environments they're working. And Bluetooth is just such a natural technology for that, because it's so low power, it's so low cost to embed into things. It can run for long periods on batteries, maybe even scavenge energy. And it's naturally built to interact with these devices. The Wi-Fi on these devices being used to connect to the backhaul. You don't want to interrupt that. Whereas a Bluetooth device can be detected transparently just as a worker goes about their job. So the main application here is these mobile computers that are milling about wherever people are doing their jobs, that they can start spotting Bluetooth tags, Bluetooth beacons, Bluetooth sensors in the background without interrupting what that worker is doing. And that's all just by installing an agent on those devices themselves that can do that in the background. So it's kind of like a free, a very simple way for companies to get additional data from things that are around the people that are doing work for them.
So why now? Bluetooth has been around forever. Why all of a sudden do you think that this has a place?
Yeah, well, I guess it's been growing, quite quietly for years. So it's not like this is, suddenly a new thing. In fact, quite the opposite. I think the reason it's taking off is because it is so an established technology. It's trusted technically. It's in all these devices, but there are, things happening. People are getting more familiar with using data from these sensors. There's a lot more interest thanks to AI making answering questions from data a lot more accessible. And then on the flip side, the actual cost of Bluetooth tags and sensors, and we're even working on sticky labels that have Bluetooth built into them. That's the cost is going down and the ability to answer questions is going up. So it's sort of a perfect storm of a technology that's been, like I say, it's quietly trotting along for a long time. But I think things compound, and I think over the next couple of years it will feel like an overnight success, but actually it's been it's been building and building. So great for us and a great time to be working on this thing. But I don't think it's anything magic, unfortunately.
There's a perception that Bluetooth is for the consumer space and for your average end user, and Wi-Fi and proprietary protocols are what you use on the factory floor. Is that a problem for somebody who's looking to implement the technology to get past that perception, whether it's real or not?
I think it's mixed. So, I mean, Bluetooth is very trusted in industrial environments and has been for a long time. It's a very robust technology. So I think for the people who understand it, there's no question. It's interesting. It doesn't take much for people to realize why it's such a good fit. So I think you're right that the general perception would be it's a consumer technology. It's what your headphones connect with, right? And that's even Bluetooth Classic. So that's not the newer Bluetooth Low Energy standard that's been out for a long time. So you're right, but I think it doesn't take much to explain things to people. That when you explain this is a technology that's in every mobile device, like billions of mobile devices, not many other technologies have that privilege. It's been tried and tested, like you say, for many years. Not many technologies have that privilege. And then when you just look at the economies, the financial economies of scale and the cost points these sorts of things can hit, I think it's like a lot of things that when you just talk to someone, it absolutely makes sense. It's nice to be able to say, oh, you've come across AirTags. Some people think AirTags are GPS. But as soon as you say, well, that's Bluetooth working now, it's like, okay, So we haven't found it to be hard. There's definitely a sort of a learning aspect to it, but no, I think it makes sense. And the fact that all these devices that a company has already invested in, you can just say, by the way, it's already got a Bluetooth chip in it. Right. Install this agent. So we call it the Beacon agent, and suddenly it gets this new lease of capabilities. No hardware to be purchased. That's really compelling. So haven't found it to be a problem, but that definitely it's something that is not obvious to a lot of people at the moment. But I think that doesn't seem to be a barrier once they start realizing what it's capable of.
Okay, there are many different definitions of Industry 5.0. I know I have my definition, but do you expect to see something related to Bluetooth included in one of these revisions of Industry 5.0, or is that a non-issue? Doesn't even matter?
I mean, I think possibly it doesn't matter. So a lot of the Industry 4.0, 5.0 is very tied to manufacturing structural lines and integrating systems and things like that, whereas what we're seeing is a lot of companies are looking for more, systems that can cope with a bit more of an ad hoc nature. They, spinning up a site very quickly, leveraging technology they already own without having to make a big capital investment to unlock new capabilities. So I do think maybe it's hard to know whether it fits under that bracket. If Industry 5.0 includes that level of understanding, flexibility and dynamism and being able to move quickly, a part of it, I think maybe it will start appearing under that. But I don't know if it matters. I think the behaviors of how companies are now operating, using digitizing everything, pushing software to the front line to understand what's going on, help employees be more effective, these sorts of things. I think that's just a general trend, and whether you name it something, it almost doesn't matter.
Right.
It may be for proliferation of a concept. It's really important, but I think it's very clear that understanding what's going on versus what was planned to go on is a big deal, and being able to ask questions of your reality is a big deal. I think that's how we're seeing it. Like the trend, whether it's that's the trend. It's the thirst for data and understanding what's really going on.
Right. And what's the Bleakin contribution here?
Yeah, well, for a lot of companies, actually understanding, I guess what would originally have been asset tracking, understanding where things that are important to your business and important to make it run are, was where it starts. And the agent that we can install on these frontline devices can immediately light up all of a company's devices as a tracking network. But I guess what's interesting is then people are looking beyond that to, well, what's actually going on? So they're looking for sensing and condition monitoring and, other types of data from these physical environments. And we've sort of taken that beacon technology and moved it to the next step where it can do that. So the fact that people can very quickly deploy almost as an IT operation, the ability to turn their fleet into a sensing network is really quite powerful. And it definitely changes the equation on how people think about rolling out technology and the risk of rolling out technology. I guess that's what we're really leaning into. This is if you can roll out infrastructure a lot more quickly and a lot lower risk, well, surprisingly that impacts adoption. That combined with the other things that, like I say, we're going on with Bluetooth sensors, Bluetooth labels. It's a really interesting inflection point for how people deploy infrastructure.
Okay. So when I have you on the podcast again next year, what are we going to be talking about?
Oh, interesting. So my suspicion is that some of the applications will have come from left field. As I say, tracking is where a lot of people think about this technology, but actually monitoring cold chain, for example, and actually what's happened throughout a whole supply chain, even when you didn't have visibility, the sort of technology we've built allows things like that. That's a capability that isn't perhaps obvious to people at the moment. And I think that might actually move a lot faster than people imagine. I think the march of these mobile devices and the using them as infrastructure will accelerate a lot quicker than people imagine. So I suspect it will be around surprising use cases and how the adoption has turned up in industries you wouldn't necessarily expect.
Well, I thought that's what this year's podcast was about. We put Bluetooth into the industrial space, and that was unexpected for me. So I definitely look forward to see what's even more unexpected for next year.
Yeah, me too.
Very good. Thank you, Simon. I appreciate taking the time.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.